All right, so our final question of the day is asking us to solve each of these inequalities and write the answer in interval notation. Okay, so I'll get into a little bit about what interval notation is in a second, but I'm going to just jump right into solving each of these inequalities. And the purposes of inequalities is to basically they're asking us to find the values of x which make these inequalities true. So each of these statements are true for certain values of x, and we have to find those values of x, okay? All right, so let's first calculate a. And also let me zoom out here and use a bigger brush. Okay. So a is -4 is less than 5 minus 3x, and this is always less than or equal to 17. So the general goal for a lot of inequalities is that you want to isolate for your variable. So in this case, we want to isolate for x, which is in between these two inequalities, right? So the first thing we want to do is get rid of 5, right? So we want to subtract all sides by 5. So to get rid of 5, we subtract as such. Okay. And if we simplify, we get -9 less than -3x less than or equal to 12. Okay. And so another rule that I want to cover before I continue is that whenever you divide or multiply by a negative number, you have to flip your inequality signs. So in this case, we're dividing all sides by -3. So we have to flip this inequality sign from less than to greater than, and this one from less than or equal to greater than or equal to. So if I divide by -3, we have 3 greater than x. And if we divide 12 by -3, we have x is always greater than or equal to -4. Okay, so if I were to rewrite this inequality, because right now it looks kind of messy, we have x is always greater than or equal to -4 and less than 3. Okay, so this is the first answer to our solution. Okay, so they ask us to write this in interval notation. Okay, so what it means by interval notation is in this notation. Okay, so if we had, I guess, x is less than a and less than b, interval notation would be x belongs to ba, right? So this is usually by notation a coordinate system, but in this case, this is what we call interval notation. And the type of bracket matters here, since if x is less than or equal to a and greater than or equal to b, then x belongs to close bracket b, a close bracket, right? So these closed bracket means that it includes b and a, while these rounded brackets means that it does not include b and a, right? And the way that we read it is x belongs to, or x is greater than b but less than a. So this is what interval notation means. So in this case here, interval notation would be x belongs to -4. So -4 has a closed bracket because the interval includes -4, but always has to be less than 3. And this is a rounded bracket. Okay. All right, so moving along to the next inequality, we have that b asks us to find the values of x, which makes this inequality true. X squared is always less than 2x plus 8. Okay, so like in the general rule, we want to isolate for x. Okay, so we want to move all our x's to one side. So to do that, we move 2x to the other side, and we have this. Okay, so this is still kind of hard to calculate, right? Because we need to find the values of x, which will make it less than 8. So why don't we make the values of x, which makes this less than 0? So we move the 8 to the left-hand side, and we have x squared minus 2x minus 8 is less than 0. And lo and behold, we just have to find the zeros of our function and then evaluate which intervals make our function less than 0. Okay. So if we were to factor this using the cross multiplication method, we have x minus 4 times x plus 2 is less than 0. Okay, so now we want to test what values of x would make this inequality less than 0. So the first interval to check if x is less than -4. Okay, so if x is less than -4, let's say x is equal to -5, we would have a negative number here and a negative number here that would equal to a positive number. So we can't have that. Okay. So the next one we want to check, okay, so we know that if x is less than -4, that translates to x greater than 0. So we don't want that. What if it's if x is between -2 and 4? Okay, if x is between -2 and 4, so x is between -2 and 4. Also, I meant to write -2 here. Okay. What do we get? Okay, so if x is between -2 and 4, let's say -1, right? This would be negative, right? So -1, x equals -1 would be -5 times negative or 1, right? So that will be x less than 0. So this is the interval where x is less than 0. Finally, the last interval that we want to check is x is between is greater than 4. Okay, so if x is greater than 4, let's say 5, then we have a positive number in both, right? So 5 minus 1 is 1, and 5 plus 2 is 7. So 7 is not less than 0. 7 is greater than 0. So x is greater than 0. So we have found our interval here. So therefore, x belongs to -2 and 4. That's the interval notation for B. Okay. So let's look at C. All right. So C, they give us a factored form of our polynomial, or our quadratic function, or actually is a polynomial, which is they're asking for the values of x, which would make this expression greater than 0. Okay, so we have a few zeros that we need to check here. So x equals 0, 1, and -2. So when x equals 0, 1, and -2 is equal to 0, right? But we want to make sure that we want to check in between each of these zeros to see whether or not it is positive or negative. Okay, so the first interval that we want to check is if x is less than -2. So if x is less than -2, what do we get? Negative, negative, negative. So that means that x is less than 0, right? Because if x is equal to -3, -3 times -4 times -1 is going to be a negative number. Okay. So next thing that we want to check is if x is between -2 and 0. Okay. So let's say x is equal to -1. If x is equal to -1, we have negative, negative, positive. So x is greater than 0. So x is a positive number. Next interval that we want to check is that if x is between 0 and 1, so let's say half. If x equals half, then it's half times -half, so negative times positive, so x is less than 0. And finally, we want to check if x is greater than 1, and it's going to be positive, positive, positive. So x is greater than 0. So therefore, x belongs to -2 and 0, or 1 and infinity. So this U-shape tells us that there are two different intervals that x is positive, that makes this expression positive, which is -2 and 0 and 1 and infinity. It's either or. It cannot be both. Okay. So let's talk about D. So D is asking us for the absolute value of x minus 4 is less than 3. Okay. So there's a rule about absolute values which states that the absolute value of a less than, let's say, x means that this is the equivalent to that, which states that we want to find a less than x and also greater than -x. Okay, so using this property in mind, we can break up our absolute value bracket to be x minus 4 greater than 3, or less than 3 and greater than -3. And this becomes a very easy inequality for us to solve because we just isolate for x. We know that x has to be less than 7 and greater than 1, and therefore our interval is x belongs to 1 and 7. Okay, so this is a property about absolute functions that you guys need to know, that the absolute function of a, or absolute value of a when less than x, is equivalent to saying a greater than -x and less than x. Okay. Finally, we are given e. Okay. So now we're given a rational function, and we want to evaluate whether when it's less than or equal to 1. Okay. So in the same method for rational functions, or I guess quadratic functions, we want to empty the right-hand side to make it equal to 0. Now it'll make it a lot easier for us to solve this inequality. So we're going to move this 1 to the other side. So 2x minus 3 divided by x plus 1 minus 1 is less than or equal to 0, right? So now we're going to include this all under one denominator. So we're going to have 2x minus 3 minus x plus 1 divided by x plus 1 is less than or equal to 0. And we have here x minus 4 divided by x plus 1. Okay. So now we need to evaluate what values of x makes this expression equal to 0. Or in this case, what values of x makes this expression equal to 0 or undefined, right? And from that, we need to evaluate in those intervals where the value or the expression is less than or equal to 0. Okay? So the values of interest here is x equal to 4 and x equal to negative 1. So x equal to 4 makes this expression equal to 0 because x equals to 4 makes the numerator equal to 0, and 0 divided by anything is equal to 0. And x equals negative 1 is also a point of interest here because when x equals negative 1, our function is undefined here, and that gives us reason to believe that there's intervals and between that. Okay. So given that in mind, now we need to test our intervals here. So let's say that x is less than negative 1, right? So if x is less than negative 1, we have that the denominator is going to be negative, and our numerator is going to be positive or negative too. That means that x is going to be greater than 0. Okay. All right. So what if x is between negative 1 and 4, right? What happens here? So if x is between negative 1 and 4, let's say 3, then this will be a negative number and this would be a positive number. So that means that we have x to be less than or equal to 0. And we want to include 4 here because we also want to find the values of x which makes this expression equal to 0. Okay. Finally, we want to test the last one, which is x greater than 4. And if x is greater than 4, we have a positive number and a positive number on the numerator and the positive number on the denominator. So x is greater than 0. So therefore, x belongs to negative 1 and 4. Okay. So all of these solutions are correct, and the solution is correct. Nice. Okay. All right, so that wraps up my lesson today. I covered 10 questions surrounded related to functions, algebra, and also long division, and also related to the quadratic formula. So if you have any other questions or concerns with your math homework or your chemistry homework, calculus homework, please submit them to OneClass and we'll get them done as soon as possible. Other than that, wish you guys a good night. Bye, guys.